So Unit 3 is about bonding, and then we'll talk specifically about ionic bonding. In Unit 4, we'll start going over covalent bonding. So first, the general overview and everything that you need to know about metallic bonding, and then just some things about ionic and covalent that you will also need to know. So first, atoms bond so that they have a full valence shell, which typically means that they have 8 valence electrons, although there are some exceptions, and one of them is hydrogen, who just needs 2 electrons to be like helium. But most atoms need 8 valence electrons to be stable and satisfied. Metallic bonding is the bonding that occurs in metals. So you have the metal cations, and the cations mean it lost an electron. So those valence electrons that the atoms are losing are just kind of free to move about all the different cations. So metallic bonds form what we call a sea of electrons. So those valence electrons are free to kind of float around amongst the metal cations. And another way of saying this is to call them delocalized electrons, meaning that they're not local to one specific atom. They're free to move. So you might also call them mobile electrons. But it's because of these delocalized electrons that we have the properties of metallic bonds. So metallic bonds have luster because of the delocalized electrons. They are malleable because of the delocalized electrons. They are ductile because of the delocalized electrons. So all the properties are linked to what those valence electrons are doing. Metallic bonds also conduct heat and electricity when they're solids. They have high melting and boiling points. And they don't dissolve in water. Okay, for ionic bonding, instead of being just metals, it's a combination of a metal and a nonmetal. And so what happens are those valence electrons are transferred. So the metal gives the nonmetal its electrons. So the metal loses the electron and forms that cation. The nonmetal gains the electron to form the anion. And then you have that bond between positive and negative. Because the electrons are transferred, we get the properties of ionic bonding. So ionic bonds are hard, rigid, meaning they have a fixed structure, but brittle, meaning we can break apart the bonds easily because they have transferred their electrons. Ionic bonds also have high melting and boiling points because of those transferred electrons. They also dissolve in water because of those transferred electrons, and they conduct electricity and heat, but they have to be in the molten phase, which just means they have to be a liquid, or they have to be dissolved. So metallic bonds conduct when solid, ionic only when it's a liquid or dissolved in water. Covalent bonds are simply between nonmetals. So we have metals, metal and nonmetal, and then just nonmetals. Now when nonmetals bond, they share electrons. And so it's because of this sharing of the electrons that we get the properties of covalent bonding. Now you can share 2 different ways. You can share equally, which we call nonpolar covalent, or you can share unequally, which we call polar covalent. And we'll talk more about polar versus nonpolar in our next unit. Remember, this is just kind of a short overview of covalent, and we'll get into more detail next time. So the properties of covalent bonding due to the sharing of electrons is that they are non-conductors, and non-conductors are called insulators. So they do not conduct heat and electricity, but they insulate from heat and electricity. The other major property is that they have low melting and boiling points, as opposed to the high melting and boiling points of metallic and ionic. The other thing, that the last property that they have, is that nonpolar doesn't dissolve. Polar does dissolve. So for covalent bonding, it really depends on what they're doing with those electrons, whether they're being shared equally or not, in order to figure out if they're dissolving or not. But that's the three types of bonding and their properties.